It is time to start going over primitive types and operators in Golang. So let's get started. So primitive data types are data types used when declaring variables. In the previous tutorial, we went over variables and we specified how we can signify what type we're going to store or what type of data we're going to store in that variable. So we went over things like ints, strings, but there's more. And we can control how big or how small the amount of data we're going to store into that variable. So yeah, a primitive type is just what we're going to use to declare the type of data we're going to store. And we usually have four groups, or we do have four groups in Golang. We have strings, which we saw before. We have numeric types, which we saw one of them, which were ints. And we have Boolean, which a Boolean just means that it's going to be either be true or false. And then we have a error primitive type, which is used to just store error messages. It's wrapped around a string pretty much, so you can expect the error to usually be returned as a string, but usually it's used for errors in a Golang project. So let's go over them one by one so we can see exactly how they look like. I already have my VS Code editor open up with a main file already opened up, so we just go step by step for each one. Alright, so the first primitive type we're going to go over is a Boolean type. A Boolean just means that it's true or false. So let's do that really quick. I already have the file open, so let's just create a variable called the truth, and I am going to make it a type bool. This just means that it's going to be a Boolean type. It's going to either hold true or false. So the default behavior of a Golang variable is that if nothing is stored inside of this variable, it's gonna automatically default to 0. 0 in a Boolean just means that it's false. So if I print out the truth right now, I should expect to see false because 0 signifies that it's gonna be false. 1, if a Boolean is holding 1, that means it's signifying that it's true. So just to show that I'm not a liar, let me do fmt println. And let me just do the truth. And let me do go run and this directory. And boom, I see false, as I expected. So yes, that's the default behavior of a variable in Golang. By default, it's 0. And 0 for a Boolean just means false. So we should expect to see false. Now, I don't always want it to be, false. You can also set it to be equal to true, no problem, right? And then if you run that again, it's just going to be true. So a Boolean just holds true or false. If you try to put anything else, like if I want to put a string, it's going to get mad at you. This is not a Boolean. It's not true or false. So that is a Boolean, and it's going to come useful in later tutorials when we start to go over conditional statements, where something can continue on based on whether it's true or false. This is going to be important because a variable can hold true or false, or we can do some comparisons to see whether it's true or false. But the basis of where it comes from, and a Boolean is what stores true or false. Now, when it actually comes to comparing, we could do that. So we know that this can store the truth, which in this case I'm gonna hold true, and we can create another variable called I'm gonna call this the false, and I'm gonna make this also a Boolean, but in this case I'm just gonna make it equal to false. Right. Now I can actually use something called a comparison operator, and what that's going to do is I'm going to use two equals, and I am going to use the variable the false. What this is doing is usually we see one equal sign, right, and that just means that we're going to assign a value to it, like the variable here. We know that we're assigning the truth equal to true, but if we want to compare two things, right, we use two equals. We're not assigning it, we're actually comparing it. So we're going to compare this variable, the truth, to the false. Now, does the truth equals the false? You guys should know the answer. If you see two different values here, that means they're different. So if let me just clear this out. If I run this, I should expect to see false because the truth is not equal to the false, right? But if I do, use the truth twice, right? And it's gonna get mad here because I'm not using the false right now, but if I run that again, ooh, the false is declared but not used. So yeah, Golang gets mad when you have a variable that you're not using. So let me just remove that. And it's obviously going to show like, okay, why using this for the same variable, but just to show that what I'm telling is the truth. We're doing comparisons. Are they equal? Yes, they are equal because they're both true, right? And I can even use the false, make that equal to true. Do the false, compare, go run. They're both equal to true. They're both the same. So this is how we do comparison operators. Like I said, in later tutorials, this is going to become way more useful when we start to do conditional operators. We can pretty much break it down like, okay, if this is equal to this, can do this, like do one task. If it's not equal to this, do another task. Like you can break it down into steps, into logical steps. We'll talk more about that in future tutorials. But that is the comparison operator, and they're very useful when it comes to handling booleans. Alright, so the second primitive type are numeric types. So that's things including integers, floats, and complex numbers. So in Golang, it provides a variety of ways to describe an int. I know in the previous tutorial we saw, var, then a variable, and I just place the type of int, right? And int by default for Golang, it just goes by the system that you're using. So if you're using a 32-bit system, then this int is going to be 32 bits. But if you're using a 64-bit system, then this is going to be a 64-bit integer. So there are cases that you want to specify a specific amount that you want the variable to hold. Maybe you want it to be 8 bits, 16 bits. Golang does provide that option to do that. So we're going to dive in a little bit deeper on the different options that Golang has to offer. So just want to describe that before we saw this int, it's based on your system, but we could describe or we can create variables that holds different sizes. So I'm going to start going over some unsigned versions of an int, and I'm going to try to write these as fast as possible, and then I'm going to go over them. Alright, so I created the first batch of variables. So I created, UN8, UN16, and vice versa. And these are just describing unsigned integers. Now, unsigned just simply means that it's going from 0 to maximum threshold. So for UN8, it's going to be 8 bits. So it's going to go up from 0 to 255. For 16 bits, it's going to go from 0 to 65,535. And then increasing. So these are unsigned integers, right? So they cannot be negative. They can only hold positive values, 0 to positive, a very max positive value. So Golang does give you that ability to signify that you just want an unsigned int in that variable. So if I try to store like a -3, it's going to get mad. This is not unsigned. It's not able to convert that. It's going to cause issues. So don't do that. But it can hold 10 just fine. No issues here. So that is the first batch. So if you know that you want a specific threshold for a variable, a specific integer from 0 to whatever threshold that you want, these are perfect. Now the next batch I'm going to go over are signed integers, which are pretty much the same thing as the one above here. We would just have to remove the u in front of the type to signify that we want a signed integer. So let me just write that out really quick. All right, cool. So I'm just taking advantage of grouping variables together. So I created, N8 to signify they're going to hold the signed value of 8 bits, and so on and so forth. Just like the same rules of what's above, everything is going to be stored up to a certain threshold. And I'm going to leave like a little box on the screen to show like the threshold of each one. But just know that this N64 holds a very, very big value. So if you know that, if you hover over it, you can see exactly that threshold right here actually. a very, very big value. So you just have to know what you expect, and maybe even a little bit more, just in case, because you don't want any overflows. Overflows is not a good thing. It just means that you go over or under a threshold that is able to hold, which can cause your application to crash. So this is just how you would store a type of assigned int, either 8, 16, 32, or 64 bits. Another type we can hold, another primitive type or numeric type, is a float. So we can do var, and we just do f8, and we're going to call this a float 32, and we're going to do f32, and it's going to be f64, and this is going to be a float 64. So just as the name implies, it's going to be a float of 32 bits, and then it's going to be a float of 64 bits. Floats just simply means that it's going to be able to hold a decimal value. So if you're going to do like a 4.44, this will be your best bet. But if you try to do that for an int, it's just going to cut it off, and it's not going to like it at all. It's going to truncate it to like 4, because that's just the behavior of an int. It's not, a decimal value. It's not a float. But if you need that, 4.44, then you just place it into a float. Now, if you know it's just going to be 4.44, then you just put that in this float 32, because that would be a waste of space to put it in a float of 64. But these are the two options that you have to hold floats. Now, the last of the numeric types are, complex. So let's do var, open up that grouping, and we're just going to do complex of 64. So let's do 64. That's going to be complex 64 and C128. So it's going to be complex 128. So complex is, if you go back to math class, these are holding imaginary numbers and complex numbers. Granted, I haven't used that in a while, but if you do need that, if you're someone that's going to use it for intensive math purposes, there is complex types. So if you need it for 64 bits or even 128 bits, they have it there for you. So these are the numeric types that Golang has to offer. We have just regular ints. It's going to be based on your system. It can either be 32 or 64. So based on whether your system can handle it. So if your system is 32 bits, it's going to be 32. If it's 64, it's going to be 64. Or if you have a specific amount that you need, like if you need it to be unsigned, so you only want positive values, you can do that. Just put a U in front of it and specify the amount of bits. Or if you want it to be signed, then you can just take out the U and just specify the bits. So int 64 and 32 if you need it. Now if you need some decimal values, you can also create it using floats. And if you want things to be a little bit more complex, you can even use complex types, 64 and 128. So yeah. Now the one type that we did for sure go over in the last tutorial were strings. And strings just means a series of characters. It's text. We see it all the time. This right here is text. This right here is text. But to specify in Golang that it is text, or that we want to hold text, we use a string, right? So you can just do, a variable called text, call it a string, and we know that we're going to assign it, first we got to open up some quotes, and then we know that we're going to assign it some characters, a series of characters. So we already did this initially. So this text is just going to hold hello world, and Golang can see that. Or even if we want to let them imply it, we can do that. So we'll just put in the colon and do that, and we can then print it if we have to. So let me just do fmt dot println, and then boom, just print that out. Go run hello world. So if you need any text, if you need to handle text, string is the type that you use. Nothing too crazy. It's just a series of characters. All right, so the last primitive type that I'm going to go over is the error type. So what is the error type? So let me just go into this definition of error just so that it makes more sense. So really an error is just an interface that wraps around an error of type string. So it is literally anything that implements error. And that's going to make more sense when we go over interface later in this tutorial series, but it's simply an interface that wraps around a error that is of type string. So we know that this error, in the grand scheme of things, is just going to return a string, a message of type string. So to help visualize this, right, I created this throw error function, and it is of type error. So I know that it's going to return an error, right? And I set this variable right here equal to the error that I just thrown. So now we have an error inside of this variable, but now let's print out what exactly is inside of this error. So let's do fmt prints ln, and let's do error. That's literally just what we saw. We see that it's when we went inside its definition, we see that it's just using this error that we defined in this interface. And let me just save that, and let me just do curl run dots, boom, new error for fun. So we're using this, we just use this errors library that helps us create a new error, and that's just being returned, and we're leveraging that error that we just created and printing that out because it's simply a string. It's simply a message. But this is vital because whenever we start messing around with things like APIs or things that may return an error, this is important because we can check for error. We can check whether this variable has anything within it. If it does, that means that we may have an error. If it doesn't, that means we could probably continue. Or things that may return an error, this is important because we can check for error. We can check whether this variable has anything within it. If it does, that means that we may have an error. If it doesn't, that means we could probably continue. As things start to become more API centric and you kind of never know what type of response is being returned, I feel like this type of type is used a lot, especially when you want to return a specific response based on an error. So yeah, this is pretty useful, and that's pretty much what an error is in Golang. It's simply an interface of type error, and the error is just a string. So as long as something implements an error, you're simply just going to be using a string.